Okay, in this video we'll be going through center of mass, and we'll also be going through how the center of mass applies in level 3, and also some practice problems to practice what we just learned. The center of mass is defined as the point at which the weight force acts through. So if we have a random looking object like this, there's going to be a mathematical point, let's say right there. At this point, if I apply a force upwards, right, we can apply this force using our finger or anything else, the object is going to remain perfectly balanced. So if I were to balance that object on my finger, the object is going to remain perfectly balanced on my finger. And this is because the weight force of the object acts through this point, directly downwards. And so the center of mass is defined as the point at which the weight force acts through. Right? Now, in our level 3 context, you're going to see that in most cases, we are going to have a situation where we have two masses. So we can call this M1, and we can call this smaller mass M2. Now, if we imagine that these masses are combined with a massless and uniform rod, because M1 is more massive than M2, the center of mass is going to shift closer to M1. So, the center of mass may be somewhere right here. And again, as stated before, if we apply a force directly through that center of mass, the masses will remain completely flat. You can imagine that if I were to apply a force over here, you can imagine that M1 is going to rotate downwards like this, because it's not balanced. Now, how do we calculate this mathematical point of the center of mass? In order to do that, we can redraw our situation where we have our M1 and our M2, again, combined with a uniform and massless rod. But we can also define a point somewhere out here, which we can call our reference point. This is what's also known as our pivot, if we are talking about torques. So now, if that is our pivot point, you can imagine that this system is going to rotate like that. So if we hold it at the pivot point, the two masses are going to swing downwards, right? And again, because M1 is more massive than M2, the center of mass is going to be somewhere over here. And so the formula to find the center of mass is derived using torques. So we know that our torque is equal to force times distance, right? And so we need to define some distances for this. We can define this as x1, right? From the reference point to mass M1, so x1. We can define this distance right here as x center of mass, and we can define this distance right here as x2. And from this, we get our formula that the x center of mass is equal to m1 x1 plus m2 x2 all over m1 plus m2. Now, in my video, how to derive the center of mass formula, I go in depth on how to actually derive this. But for now, this is really all you need. Now, a small little tip when calculating the center of mass is to set M1 as the reference point. So if we go back up here and we set M1 as the reference point, you can imagine that x1 is going to equal to 0, because x1 is our point from the reference point to M1. So if M1 is the reference point, then that x1 distance is going to equal to 0. And so in our equation, if x1 is equal to 0, that means M1 times x1 is also equal to 0. And so that term cancels out. And what we get is x center of mass is equal to m2 x2 all over m1 plus m2. So that dramatically simplifies our equation. So now, using that knowledge, we can go on to some practice problems. So now, if we have a situation where we have a larger 10 kg mass and a smaller 6 kg mass, the distance between these 2 points, let's say, is 5 meters, and our center of mass is going to be somewhere over here. So now, again, setting M1 as the reference point, in this case, we can call our M1 our 10 kg mass. So if our 10 kg mass is our reference point, that means the only distances that we need is our x center of mass and our x2, which we know is 5 meters. So using our equation, x center of mass is equal to m1x1 plus m2x2 all over m1 plus m2. Again, because we used our tip, x1 is equal to 0, and so this term cancels out. So that means our equation is m2x2 all over m1 plus m2. We know our m2 is 6 kgs, multiplied by our x2, which is 5 meters, all over m1 plus m2, which is 10 plus 6. And that gives us a center of mass of 1.875 meters. And so what that means is that this distance right here is 1.875 meters. So the center of mass is 1.875 meters from the 10 kg mass.